Hello, everyone. Good morning, good afternoon, and good evening from wherever you're joining us from. My name is Dalia, and I work as a community manager here at Kong. I'm super happy to have you at our first user call for 2025. So welcome. Today, we're going to talk about services, multi-zones, and load balancing in Kong Mesh. We have Mike with us today. I'll let him introduce himself. We have Q&A function on the bottom. You can see it on the bottom here. So please include all of your questions there, and we will answer them as soon as he's done presenting. Also, this webinar is being recorded, so we will send you an email after that with the recording and some useful resources which you can use. You can also find the recording on our YouTube channel later today. So yeah, please, Mike, take it away from here.
Okay, thanks, Dalia. Yeah, as Dalia mentioned, I'm going to be talking about services, multi-zone, and load balancing Kong Mesh. And kind of the reason that we're talking about this is that we recently introduced in the most recent minor release of Kong Mesh 2.9 a change to how we do services. So I'll talk just like a little bit about services in general, and then how we use them, how they work, and what they are in Kong Mesh, and then how to use them with multi-zone, and then also how to do like various kinds of load balancing with them in Kong Mesh. So first of all, let's just like kind of do a basic discussion about what a service is. Typically, a service is kind of an abstract concept. And typically, when we have like a microservice application, then we're going to have like multiple instances of a service. And so you'd have like some pods. And what makes these pods part of a service is that they all fulfill like some kind of contract, like the same API, for example, and the same version of the API, so that you know that when you send a request to any of these instances, it doesn't matter which instance you reach, but whatever when you do, the same thing will happen, right? And there's more than one of them in order to have things like high availability, in case they're unstable, or for anything, and to scale up in the case of increases in traffic, and scale down. So yeah, like we can imagine the number of pods that belong to a service, and the service is what we're concerned with today. And I'll then talk about so next I'll just talk about what a service is from the point of view of a client that's using the service. And in particular, how does a client that sends traffic intended for a service verify that like the destination of the traffic that it's sending is really like part of the service? So like in Mesh, we always have, or we don't, you can use Mesh without MTLS, but kind of MTLS is a basic part of Mesh. So we use MTLS to verify the both sides of a connection, the client and the server, or the sender and the receiver. And so when we talk about sending a request, in this case to Redis, say, every instance, every workload in the mesh has like a sidecar, right? That's how Kong Mesh works. We have an Envoy sidecar. So all traffic is between the Envoy sidecars. And when a client sends traffic to Redis, it needs to verify that the traffic is going to really part of the Redis service. And it does this by checking the certificate. It uses TLS transparently to the user, but the Envoy sidecar checks the destination certificate. And in particular, what it does is it looks at the subject alternative names that the certificate contains, that it matches what it expects. And in this case, it expects like a SPIFFE ID. SPIFFE is basically just a format for a URI subject alternative name. And we can see here, like, it basically contains the name of the mesh. And in Kong Mesh, there can be more than one mesh or sub mesh, you could think of it. But we'll just be talking about like the default mesh, which is totally fine to use. And then we have like the name of our service here. And then the client verifies that the certificate is signed by the CA that it expects. In this case, the CA that it knows about from its own like communication with the control plane, right? But it doesn't use the control plane to verify this. It just looks at the certificate presented in the TLS connection and verifies it. Yeah. So what we have in Kong Mesh is the idea of a thing called a data plane, and basically it should really be called data plane proxy, but it's called data plane. But what it kind of represents is like an Envoy sidecar, right? So kind of the whole workload. And this Envoy, this data plane resource defines like what we call inbounds, which are like the ports that this sidecar presents to the mesh, right? And each port has obviously a port number, and then it has like a number of tags that kind of describe it. And we'll kind of see how the tags are used later on. But yeah, so this resource represents kind of the instance, so not a service, but an instance. And then the service concept is built off of that. And yeah, so each workload, of course, you can't just like you can't just request any random certificate from the control plane and it will give it to you, but rather it verifies that you present a service account token that it expects on Kubernetes, and otherwise, like we have a Kubernetes independent token concept as well. So that's how the security there happens. So yeah, we'll just be assuming MTLS in the rest of this presentation. So what is a service? Well, now with 2.9, a service is actually like an explicit object. And like on Kubernetes, you have the mesh service resource. And this service is very, very similar to the Kubernetes service, which is intentional. And in fact, it's auto-generated. So while this exists as like an actual resource, you don't ever have to create it. It's on Kubernetes created from the service object, and then in Universal, it's actually automatically created as well from those data plane objects. But the important thing is that a service is now three things basically make up a service. We have like a list of identities, and these identities are the spiffy IDs that I was talking about before in the MTLS certificates. It has a list of ports, and it has a selector which basically tells the control plane which data plane tags, and those data plane tags are these tags here, belong to like any data plane that matches those tags then belongs to the service. Yeah, and previously the service, like, so now the service is a descriptor of data planes, and then each service has a number of ports. Previously, it was previously there was no mesh service object. Previously, we just had this kuma.io/service tag, and every service like was implicit because some data plane was tagged that way. So the advantage here is that you now can just like look at with kubectl, for example, just like get mesh services and just see all of the mesh services that exist in your cluster, and you can label them, and the labels come in handy with policies and general just sort of managing of your Kubernetes resources. Yeah, so that was kind of one of the big changes in 2.9 was the introduction of this mesh service object. So, okay, we have these mesh services and we have these data planes. Now, how do you send traffic to a service? You send traffic to a service, you consume the service by using its name, and you can always get the name, like, for example, with Kubernetes by looking at the list of mesh services, and you can see there's like a column here for host name, right? So you can, of course, always use Kubernetes DNS name. That doesn't change, but this is kind of an independent naming. And I'll talk a little bit about names in the next slide, but yeah, you basically just send a traffic to the name, like as before, but this time you can see directly like which host names are available for which services. And then you can, of course, use any of the ports, defined in this list, like you would expect. Yeah, of course, that doesn't actually make sense. It's a curl to Redis, but you would send a Redis CLI, for example, command to Redis. But yeah, so that's one thing, is consuming the service. The next is applying policies to the service. And you do that with our also like relatively new policies, which are based on target ref, which is like this concept from Gateway API. And you can just target so in this case, you would set a timeout. What this is doing is setting a timeout for all workloads in the mesh. Any request to the Redis service in the Kuma demo namespace get like a connection time, so a TCP connection timeout of 3 seconds. And yeah, basically it's similar to how it was before, but previously the mesh service was like, you could use kind mesh service, but this name was this implicit name that I mentioned here. Now it's like you can look at a target ref and you know that this object exists in the cluster. So that's kind of a big improvement, just the explicitness of everything. And yeah, as I said before, the names here come from host name generators, which is another new resource. There's default host name generators for like basically, so you always get a name, but if you want to generate your own names, like you can customize this template, right? You can do that. And some example reasons would be like migrating. So if you have this like already reachable via whatever in your service, you can just continue to use this name, so you don't have to change like how your client application accesses the service, right? You can just change what the name of the service is, and then it will go like to the service as opposed to wherever your service was before. Yeah, so that's kind of a host name generator. Also, not something you typically have to worry about, but it can be useful to know at least how this works. And yeah, so you can select like, okay, I want to generate using this template a name for all of the mesh services that match these labels. The labels being these labels here. Yeah, so that's another component of the new service functionality. Yeah, those are the two major components for like a single zone when we're talking about traffic within a single zone or a single zone mesh. It becomes more interesting with multi-zone. And just to recap on multi-zone, basically you have a zone is like a flat network. So inside a zone, every workload can reach like other workloads in the zone. But in order to reach another zone, you have like an ingress and egress point. So in this case, we have like, these would be, for example, two clusters, right? Two Kubernetes clusters. And in this case, traffic leaves, if traffic is intended to go from west to east, it leaves through the egress point, enters through the east ingress point, and then continues on to whatever it's supposed to go. And yeah, so this is kind of useful in cases of like, yeah, redundancy, any kind of like topological organization you have. You can, keep requests in a zone when it's because it makes like, I don't know, it's cheaper or it's faster. You can keep them inside a zone, but you can still have them within the same mesh, so you can introduce connectivity if you need it. And that's kind of what we'll be talking about next. So the first thing is like the mesh service object is always particular to one zone, but it can be used to move traffic from one zone to the other. So if we're in West right now, we can see that if we look at the list of mesh services, we can see that there's this synced, in this case, it's synced from like, because we have the global control plane as well, which is not here in the picture, but there's always a global control plane sitting between all of the zones. And in this case, when we create a Redis service in East, it's synced up to global and then synced over to West. So West knows about all of these services in East. That's what we see here. And we see the host name here, which is also from a host name generator that looks for services like this that are cross zone. We can send traffic to this service.east.mesh.local. And so we can move traffic from west to east, specifically east. So the Redis service in east by using this name. And we can also target traffic. So in this case, the traffic from west to east by targeting a mesh service like we did before. But in this case, we use labels. And these labels are going to be, in this case, auto-generated. These three labels are going to be auto-generated because, display name is something that's set. It's the original name in the other zone, right? So we have a Redis. It's in zone east, and it's in the namespace Kuma demo. In this case, we want to add this request timeout. So that's a way to target. So in this case, we would be inside the west zone with this resource, and we would be targeting traffic from west to east to Redis in east. That's mesh zone, mesh service, cross zone, always to one specific zone. Now, there are more interesting ways to do cross zone traffic. In particular, you can you can say you want to send a request to Redis. Doesn't make that much sense for Redis, but that's okay. You can send traffic to any zone. So you could load balance between zones. You could have a preference for your local zone. So in West, if backend is up here, we send front end to backend, right? So it just stays inside the zone. But if backend is down, then maybe we want to, as a fallback, send traffic over to backend in East. And that's something that we can do now using a new resource called Mesh Multizone Service. Previously, this wasn't an explicit resource either, and there was a kind of implicit relationship between these backend services where, like, if they had the same name, they had the same namespace, then the mesh kind of treated them the same. And so by default, you would, like, as a front end, you would just like you would get traffic sent to any of the zones, and then you could control this, but it was a kind of strange default where you kind of have to opt out of kind of complex behavior that should really be an opt-in situation. Yeah, this was this kind of like namespace sameness idea, which you can still do, but yeah, it was a bit surprising that it was the default. And same problem as mesh service, that you couldn't actually see like cross zone, like what services exist, right? So you could look and you could see it, your data planes existed with backend as the service tag, but you couldn't easily look into the other zones and see what like same services were in the other zones. So that's something we changed with this mesh multi-zone service. It's kind of similar to mesh service, except instead of selecting data planes with data plane tags, it selects mesh services by checking the labels. And in this case, we're basically creating a top level service which will gather any instances from any zone that have the display name Redis and the namespace Kuma demo. So it would catch the Redis from the previous slides, and we define the ports explicitly. And this is applied on the global control plane, which also in a bit in the demo exactly how that kind of works, because we'll see global and two zones. But yeah, it's kind of like a higher level mesh service which selects mesh services itself, right? Yeah. So hostname generators work here too. Same idea as before. We select mesh services via labels. Here we're selecting mesh multi-zone services via labels, and we can use the same kind of template functionality. We can look into our cluster, see which mesh multi-zone services exist, and we can see the host name. And when we send traffic to this host name, we're not just sending traffic to one zone necessarily. We might be sending traffic to multiple zones. We might be sending traffic preference to one zone. But yeah, that's kind of the difference of a mesh multi-zone service. So we'll look at that as well. And for both of these, options, mesh multi-zone service and mesh service, you can use the mesh load balancing strategy policy to define how exactly traffic flows when it comes to multiple zones. So in this case, like the default for this mesh multi-zone service would be, in this case, if I'm in zone west and I send traffic to this HA Redis, or to, let's just say here, this Redis, if I send traffic to this Redis host name, then there's a preference that the traffic stays in my local zone. If the workload is down in the local zone, then it will go to some other zone, right? We can control this behavior and many other things about load balancing with the mesh load balancing strategy. So we can, in this case, for example, disable locality awareness, which just means this idea of trying to keep traffic in your own zone. Yeah, so that's kind of the building blocks now of the new service strategy. Let's go into a demo. Okay, so what do we have here? We have global at the top. Maybe I can make this a bit smaller. We have global at the top, which again is kind of this like coordination control plane. There's no workloads running in it. And we have west and we have east. So we can look in, for example, west and see that we have no mesh services. Oh yeah, so I mean, obviously this, I didn't show installing Kong Mesh, but yeah, so I have 3 Kong Mesh installations already done here. So yeah, we're doing cross zone traffic. So what we need to do first of all is we need to enable MTLS for the mesh. So we'll just be using the default mesh like I talked about before. And then we need to enable mesh services since it's not on by default. There's different compatibility options here, but I'm going to be talking about the exclusive option, which is the right option to use when you're starting a new cluster. The other options are more about migration from the old way to the new way. Yeah, so we'll apply those 2 things. We'll enable mesh services exclusively, and then we'll enable MTLS on this mesh. And then the second part about the cross-zone traffic is that we need to enable mesh traffic. Using mesh traffic permission, we need to enable, basically traffic from anywhere to anywhere. And that looks like this. So you could, using this, you could limit traffic to, so one zone can't communicate with any others. But for our purposes, we'll just apply these two policies, and we do that on the global control plane, and those changes are then synced to each zone control plane. Let's see. Yeah, so okay, now we're on the west, right? And we can see that those two changes were applied. Yeah, now we have that. And what that allows us to do is, yeah, any kind of cross-zone traffic. What I'll do now is, since we have no workloads, I'm just going to apply, yeah, we have this little Kuma demo thing, which is just basically like a front end sending traffic to a Redis. And I'll apply that on the west zone. And we're going to be sending traffic for now to this is like a Kubernetes DNS name, right? It's not a mesh DNS name. This is just going to be this service. This is just going to be this Redis service that we're going to be sending traffic to. So yeah, so we're just going to be sending traffic in one zone to from one workload to another, basically. Let's see, let's apply it, and then we can see what happens with our mesh services. Yeah, so we have demo app and we have Redis. Now, by default, we actually don't generate an additional host name for Kubernetes services because the Kubernetes DNS functionality is already taking care of that. We can look on our other zone, though, and we can see that we already have host names generated for the two services that we introduced on the west zone, right? So in the east, we can theoretically already send traffic from east to west using these names. Yeah, let's go into this. Let me just set up the port forward. That's actually not really that interesting. Let's do something instead. Let's just look at the demo app. Yeah, so this is the demo app. Very simple. We're in West. We have we have our demo app front end sending requests to our Redis backend, and we can see here, this is our Redis counter inside Redis, and each Redis knows what zone it is. So in this case, it knows it's the West zone. Now what I want to do is apply. Yeah, we can. One thing actually that might be interesting is if we scale down just so we know what it looks like, we can scale down the Redis deployment, and yeah, so port forward needs to be set back up. Yeah, so we can't connect to Redis. Okay, that's what we expect, right? We only have one instance. Yeah. Now let's apply a very similar set of manifests, except that we just say that our Redis is in the east. And yeah, so let's just apply that. We'll see the effects of that in a second. Yeah, let's look at that. Okay, so actually the other zone is more interesting. So yeah, as we kind of pretend our Redis is down, right? In the west zone, let's see what we can do about that. Now in the west zone, we see that we have a Redis in the east zone. So what we can do is edit the deployment of the demo app. And instead of sending traffic to our local Redis, instead we can send traffic to the east Redis here. And once we apply that, and that's done initializing, and the other one's terminated. We can port forward. And yeah, and so now like we're in the west zone, sending traffic to the east zone via this name that I showed here. Right. So now we're not just communicating in one zone, we're communicating from one zone to the other. And always from one zone to the other. So in this case, if I again edit the deployment of Redis and I scale it down to 0, then we should start failing again. Yeah, so we for the port forward to come up. Yeah, so we can't connect to Redis. Okay, so yeah, so we're still dependent on one zone. And I talked before about mesh multi-zone, something that can give us high availability. Let's look at using that to kind of solve this problem of one zone being down. Let me just bring them back up before doing that. Just easier. Okay, we have. Okay. So let's look at our multi-zone service here. So this is the mesh multi-zone service that I've created here. Yeah, we're gonna call it Redis. It's gonna select any mesh service that has the display name Redis and the namespace Redis demo, and we can kind of see we can kind of see which ones that will be here. If we look at, say, the mesh service in Kuma demo, we can see that it has these labels. Well, in this case, it has an annotation, which is kind of a technical thing, but essentially it also checks annotations. And in this case, we have the display name Redis and we have the namespace Kuma demo. So this label matcher will match this mesh service, which is the one local to east. And the synced objects are in a different namespace, but if we look at this synced object, we can see the same labels. We can see namespace Kuma demo, and we can see display name Redis. So if we apply this, which we have to apply on global, actually. Yeah, so when we apply this, we'll see that those two services are matched, and yeah, we should have access to this port on those services then. So let's apply it. Again, we're applying on global because this is a sort of global concept. That's the only way to do it at the moment. Yeah, and now we can see we have a mesh multi-zone service in our west zone, and it has the host name redis.mz svc local. Yeah, so we have a host name we can use, which should give us some cross-zone, multi-zone functionality. Right, let me just edit the deployment directly. Host name. All right, now we'll port forward back after the pods are done. Let's port forward. Okay, so we're using that new name, and we see that, again, we're in West here, the West front end. We see that when we send a request to Redis, it's going to the West zone. That's the locality awareness by default that I mentioned previously, which we think is a sensible default because probably it's going to make sense to prefer a local zone. Yeah, so that's that. Let's see what happens if we again scale down Redis in our local zone, the local Redis in our zone. So okay, that's what we wanted, right? So we fall back to east. We scaled down the west Redis, and now our requests go to east instead, and that's why we have, zone east here. We have a different counter. So we, of course, it's Redis, so we have two different states, but you can see the functionality that's happening here is basically a failover functionality that protects us from our service going completely down if it goes down in one zone. Yeah, that's that. That's the default behavior. go a little bit into mesh load balancing strategy. There's a ton of stuff you can do. Check the docs for mesh load balancing strategy. There's like different hashes you can do and different hash algorithms you can use to distribute traffic. And you can do like, you can add topologies even within one zone, and you can prefer like, yeah, prefer workloads tagged one way versus another. But just what I'll do here is just disable the locality awareness that I mentioned before. And what we should expect here is, well, actually, let me scale this back up locally. I need, you know what, I'll just open a new forward west. Right, so let's just make sure it's working. Yeah, so now our Redis in West is back up, so we're sending traffic solely to Redis. I'll just turn on the auto increment here. I'll go to global and apply the load balancing strategy I just talked about. So we're targeting, so this means that we're targeting from the entire mesh to the mesh multi-zone service called Redis. We're targeting that, and we're setting the locality awareness to be disabled. So we'll apply that. We can even see that in the West now we should have, yeah, we have a copy of this, which again is being synced from by global to each zone. Yeah, in this case, what we see when we go back is no longer a preference for West, but rather just normal load balancing between East and West. And yeah, that's kind of one of the options that you have for configuring load balancing. Yeah, I think that's the demo. Again, check the docs for mesh multi-zone service, for mesh service, and mesh load balancing strategy to see all the kinds of stuff you can do. But yeah, we're pretty happy with how this worked out. We think it gives a lot more visibility into the state of the cluster, a lot more control, and yeah, I think the explicitness is a big win. I think being closer to Kubernetes is what users expect. And yeah, I'll stop there. Keep sharing in case
Thank
we
you,
need to
Mike.
go. Yeah,
Amazing. Let's see now. We have, I think, one question in the Q&A.
let me check the Q&A. Cross communications happens. How exactly communication? No. I mean, Kongmesh ensures minimal latency because it by default does locality awareness load balancing, right? So it ensures minimal latency by preferring the local zone, which presumably has the lowest latency. And you can, depending on how like the topology of all of your zones look and what you know about those zones and their latency characteristics, you can then use mesh load balancing strategy to further prefer one zone versus another. So you could have like, you know, more than one level of fallback. You could prefer local. If not local, then north. If not north, then south, right? So it's kind of like we give you the tools to take all the latency characteristics you know about into account. And yeah, then it's kind of up to you to set those in a policy in mesh load balancing strategy. Yeah, so that your traffic, you know, works the best for your topology. Does that make sense? Let me check chat as well. Okay. Yeah.
Let's see if we have any last questions. No. Okay. Well, thank you everyone for attending. Thank you, Mike. Oh, wait. Nope, there's no one. Thanks, Mike, for the presentation. I'm going to send out
Thank
a
you.
follow-up email today later on with the recording and the resources you can use. And we hope to see you at our next user call in February. Have a great day and great evening, everyone. Bye-bye.
Thanks, everyone.